mystery answer because I've got my wonderful theta over there, or as one of my boys said today, the theater, ma'am. And I was like, no, not the theater.
Theater, theater, I've heard those, but theater, never.
The theater. It was wonderful. Yes, the theater has a side opposite to it. And then opposite to my 90-degree angle is my hypotenuse. Now, if I have to look for something that uses op and hype, that's going to be my saw, O and H. That is what I have. What do I have? I have my opposite side and I have my hypotenuse side. What do I want? I want my angle. I want my angle. And every time I see that I need an angle, I always need to shift angle. So shift, click shift, so that we don't forget that we are looking for the angle, therefore we need to shift. So just like Funzo said, we have to use sine, and we know that sine of theta is equal to the opposite over the adjacent. Wow, yo, guys, I'm also tired. It's Monday. The opposite over the hypotenuse. Okay, and we're looking for the angle today. So we're going to go the sine of theta is equal to my opposite side is 51 over 54. And because I'm looking for the angle, I'm going to click shift on my calculator. Theta is equal to arc sine of 51 over 54. And I'm hoping somebody will help me out and punch this into the calculator and let me know what the answer for theta is there for. Theta is equal to, Michael says 0.01. That sounds a little funky for, I don't believe it's 0.01. Michael's calculator may still not be in degrees, I feel like. Funzo and Michael, did you both click shift? Mateo says 10 degrees. I don't think it's 10 because I'm looking at it on my calculator right now. Funzo, yes, that's it. That's the one I'm looking for. Thank you, Emilio. Thank you. Oh, Mateo, I see you now. Mateo's like 10 instead of like a 1 instead of a 7. That's it. We're looking at 70.81. And because it's an angle, we need to remember that angles are measured in degrees. All right. So a lot of the videos that we've already done, we've already been past quadratic equations. You can find those on the app. So however, I don't want you to leave us yet. I do want you to have that first class experience before you leave, just so you can get a feel of what we're doing. And how we do things so that you can understand how to join the classes at a later stage. All right, we are on lesson 5 of 6 of trigonometry, and we had started talking about the Cartesian plane. Now, we hadn't quite explained the Cartesian plane 100%, so I'm going to do that now to make sure that we're all understanding what's happening. Now, we've all seen the Cartesian plane, the Cartesian plane. Wow, the Cartesian plane before today. So we know that this is our x-axis, right? And this is our y-axis. We're all very used to this. And Makolive, I'm going to explain all of that to you in just a bit. All right, so we're going to be looking at the Cartesian plane, and we're going to be looking at it in coordinate plane form. But we're also going to be looking at it in degree form. We're going to be looking at it in its polar coordinate form. So if I had to say to you guys, let's say, for instance, I've drawn these lines and I've drawn a protractor. I've got a protractor and I put my protractor at 0 degrees over here. Now I'm going to start measuring on my protractor going in this direction. Okay. How much would my protractor read when it reaches this line? How much would my protractor read, guys? Tell me in the chat. You can pop it in the chat. That's it. Okay, everybody who's saying 90 degrees, you're onto something because this is the 90-degree angle. So up top here, it's going to read 90 degrees. Excellent. 90 degrees. Michael, it's not one or the other. Okay, it's either 90 degrees or 180 degrees. Pick one. Pick one. Okay, it's 90 degrees. And then if I come all the way, if I come full circle over here, this is going to be 180 degrees. And then let's go all the way down here. How much is this one going to be? Remember, I started my circle over here. That's it. That's it. Yes, Abuile. That's it. It's 270 degrees over here. And I hope we all agree that as I come around all the way to the end over here, 0 degrees can also be considered as how much? Yes, that's it, Mawande. My full revolution can also be considered 360 degrees. So 0 degrees and 360 degrees are sitting in the same place. Now, let's go back to the coordinate plane. I'm going to draw a dot over here. Right. And then I'm going to put this polar coordinate of my dot at the numbers 4, 4. Now, we've seen this before. We've seen dots on a coordinate plane before. We've done, you know, and the equation of a straight line. We did that, all of that in grade 9. So we are familiar with the fact that this over here is my x coordinate and this is my y coordinate. Shaden, I would suggest that you do. It's quite important that we understand the concept that's just happened. Right. Yes, that's it, Lishe. Okay. Now, what I'm going to do here is I'm going to go from my origin over here, which is 0, 0. And I'm going to draw a straight line. And this always gives me anxiety, so I need to make sure I do it correctly. All right. I'm going to draw a straight line. Okay. And then I'm going to ask you guys, because this is a straight line, I want you to tell me, not using a calculator, not using a protractor, I want you guys to find me this angle over here. This one, from my 0 degree mark to here. Now, we already know, guys, we can already tell that between 0 degrees and 90 degrees is going to be a specific angle. And I see many of you saying 45 degrees, ma'am. I want somebody who said 45 degrees to explain to me how they got to 45 degrees. No problem, Puseleta, welcome. Did we guess? Okay, I want us to do this in the chat. Write guess, write the word I guessed, like this. Guessed, if you guessed the answer, or calculated if you actually figured out how to calculate it. So you're either going to write guessed or you're going to write calculated. Mateo's like, I'm saying 45 because everyone else is saying 45 degrees. Did we guess? Okay, Kehoratile definitely guessed. Letabo said she calculated. Kanyisa's like, I divided 90. Okay, and to some extent, you guys might be correct, but this is not going to be 100% true. Emilio, it's not particularly 45 degrees. In this instance, it might be 45 degrees. Yes, we're gonna name this theta. Remember, theta stands for the angle. Okay, so we are not 100% sure how we got to this answer. So we're gonna have to figure out how exactly we could possibly get to this answer. Now, I want you guys to, okay, stay with me, bear with me as I'm trying to explain this. Now, on my x-axis over here, I'm going to put my units for x. So are you guys going to agree with me? To get from my origin over here to that dot or to that coordinate that we have, I'm going to have to move 4 units to the right. So I moved 4 units to the right over here, and this landed me right underneath my dot. Yes, give me a thumbs up if you understand how I got 4 units. Mawande says yes. Excellent. Okay, cool. Now I'm going to ask you guys now, if I want to go from this dot right underneath. Okay, Monde and Puseleto, who's a little confused, we just started, and Mateo and Shaden, hold on. Okay, if I have my x coordinate, guys, that tells me that from here to there, that's how far my coordinate is from the origin. Okay, so if my coordinate, guys, if my coordinate was 2 and 1, this tells me that I had to move 2 units in the x direction and 1 unit in the y direction. Okay, that's what this is actually telling me. So if my coordinate right now is 4 and 4, that means I had to move 4 units in the x direction. And then from here, how many units up do I need to move in the y direction, guys? Look at our coordinate. How many units up do I need to move? That's it. I need to move 4 units. So on this side, I'm going to get 4. Okay. And if we think about what's happened over here, okay, what teacher Coco's actually done is she's created a right angle triangle. And do we know anything? Anybody know anything about trigonometry and right angle triangles and putting things together and making them work? Of course we do. Of course we do. We've learned about these. We've learned about this. We know that if our angle is over here, tell me in the chat, guys, the angle right next to it, or the side right next to my angle is called my, I did, Michael, I did. It's called my adjacent side. So my x value over here is going to be the same as my adjacent side. Do you guys notice it's on my x-axis? So my x-axis is going to be my adjacent side to my angle. Now, what about this side all the way over here? It's my opposite side, right? But this opposite side, which part of my axis does it represent? My x-axis or my y-axis, guys? That's it, Mawande. Good. It represents my y-axis. So it's going to be my adjacent side will be my x-axis and my opposite side will be my y. Okay, because if you guys notice, this line that I've drawn over here is actually parallel to my y-axis. That's why, Michael, that's exactly why. It's because this line that I've drawn is parallel to my y-axis. So we can look at it as my y value still. Okay, they're parallel to each other. They're both moving together, going up. Okay. All right, so we've now got this. What we're going to need is my hypotenuse. Remember, we still have to find a hypotenuse. But in this case, we're not going to call it a hypotenuse. We're going to call it R. We're going to call it R for radius. Okay, and the reason we call it a radius, if you're with us on Wednesday, you will remember. If, let's say, for instance, this was a string. This was a string over here. If I made a tiny little knot at the end and I stuffed a pencil in there, I can use this string to draw a full circle right around my Cartesian plane. And from the center of my circle to that dot, what do we call it when we draw something from the center of my circle to the circumference? We've all done and like geometry, this kind of geometry back in school when we were learning about circles. The diameter would be from one side to the other, Mateo. So the diameter would be from here all the way over there, right? No, it's not called a revolution. Guys, if I had to measure from here to here, what do we call this? That's it, Jonathan. It's called a radius. Okay, so we're going to keep with that terminology. We've already learned that it's called a radius, so we're going to continue calling it a radius. Okay. I hope that makes sense, guys. All right, it's known as a radius. I'm not gonna go too much into it. We're just gonna go ahead and call it a radius. Now, I know, oh, look at me. All right, I know that if I want to calculate for theta, we can go back. Hold on, Shaden, it's gonna make sense in just a little bit. We can go back to Sol, Ka, Toa, right? Think about this. We know that this side over here, okay, I just want to write it over here. It's called my X now. And this side over here is called Y. Okay, this side is actually my adjacent side, and this side is actually my opposite side. Right, if I wanted to calculate for my angle theta, what do I have, guys? I have, that's it. What do I have? I do not have my hypotenuse. I don't know what my hypotenuse is. Which two sides do I have? Good. I've got my adjacent side and my opposite side. Which formula or which ratio am I going to use? The saw, the car, or the tower? Good. We're going to use the tower. Good. Because I want my angle, and tower is going to use opposite and adjacent. So we're going to use tan. We're going to go tan of theta is equal to opposite over adjacent. But I want us to add on to this. Shifaro, we're going to explain in just a little bit. Okay. I want us to add something to this. Tan of theta is not just opposite over adjacent. Tan of theta is y over x, because it's the y-axis, or the number on my y-axis divided by the number on my x-axis. So tan of theta on the Cartesian plane can be expressed as y over x. Okay, we're going to be doing the exact same thing, guys. We're still going to be using opposite and adjacent, but instead of writing opposite and adjacent, I want you guys to also add this part. Okay, I want you to add that part in there as well. Okay, I want you to add that. Do you guys understand what I mean? Good, so we're going to have to find the answer. Mateo, remember, you need to find me the answer. Tan of theta is equal to my opposite side, or my A side is 4, or my Y is 4, and my adjacent side or my X side is 4, right? So if I want to find the angle, I click shift because I want my angle. So I'm going to go theta is equal to arctan of 4 over 4, and you guys are going to notice something very funny, that your answer is in fact 45. So you were all correct. The only reason I didn't agree with you guys is because you were guessing. I didn't want to agree with you guys because you were all guessing, but I chose this question on purpose. Puseletso, yes, but if you can still use O and A, it's fine. But I'm going to show you an example where O and A might not work for us. Okay. Yeah, I'm going to show you an example where O and A is not going to work, because we're going to have to do a little bit of shifting and maneuvering to understand what's happening. All right, give me a number out of 10. 10 being, I understand the example that you've just given me. 0 being like, yo, ma'am, you're speaking Greek, French, anything, but you're not speaking English. All right, okay. I can work with 5s and 7s and 8s and 9s. I can get you guys there. Okay, I know. For now, we still do, but we're going to be learning about special angles. So in a little bit, the calculator is going to go away. We still do need it for now, but okay. All right, now here's our next challenge, guys. Here's our next challenge. I want you to find me, if we have our angle, we've now figured out that our angle is 45 degrees, right? I want you guys to express the sine of theta in the form of opposite over hypotenuse, because that's the saw, or I want you to put it as my opposite, which is y, over my hypotenuse, which is r. Okay, has anybody noticed a problem? Anybody noticed? If I ask you to find sine for me, what is my problem going to be here? Anybody figured out the problem? That's it. Okay, Letu, I know you're asking a question, but you've actually hit the nail on the head. we don't have the hypotenuse. We don't have the r. So in order for us to continue, we're going to have to find r. Okay, bonus points for anybody who can remember, how do we find r? Oh, that's it, Funzo. Like I would throw a sweet at you if you're sitting in my class. I would like throw a lollipop at you because you're excellent. We're going to use Pythagoras. Okay, and we're going to use Pythagoras to find our r so that we can express the sine of theta as the opposite over the hypotenuse. No worries, Alicia. Okay, so I want you guys to use Pythagoras to find the hypotenuse or the r for me. Now, in this case, you can use either one. You can either use the opposite squared plus the adjacent squared is equal to the hypotenuse squared. You can use that one, or you can use the one that we're learning about now. My opposite is actually called y. So you can go my y's value squared plus my x value squared is equal to my r side squared. Either one of these, doesn't matter which one you use. Give me an answer for H or for R in the chat. Don't forget to write your reason. Our reason is always going to be Pythag. Okay.
Teacher Coco, can you also
Yes,
use the trig ratios like saw and car to find?
Absolutely, we can. Yes, we can. Teacher Nels is on the money there. She's on the money. We can actually use, because guys, if you think about it, if I'm looking for the H side, I have O and I have my angle. I have the O and I have my angle. I can find the H. And I can also use the car because I have my adjacent and I have my angle and I'm looking for my H, right? So if you guys do this correctly, you should get 4 squared plus 4 squared is equal to r squared, or is equal to a squared, it doesn't matter. This should give you 16 plus 16, which is going to give us 32 is equal to r squared. And if you punch this into your calculator, it's going to give you, remember, you need to find the square root of both sides. It's going to give you that r is equal to 2 square root of 4, I believe. 2 root 4. That's what your calculator should say. And we're going to keep it that way. We're going to keep it at 2 root 4. We're not going to be fancy
Other
about
way
it.
around. 4 square root of 2. Yeah.
2, 32, 16. Yes, sorry, 4 root 2. Yes. 4 root 2. Okay, yes, 4 root 2, other way around. So our radius or our hypotenuse is r is equal to 4 root 2. See, look at that. My one day tried it with sine and he got the answer. That's it. That's exactly what I was hoping for. You can do it either way. All right. Now, guys, I want you to express sine of my angle in the form of opposite over hypotenuse. We're not done. You still have to write for me that sine of 45 degrees is equal to, what is my y value over my x value? What is it going to be? My y value or my opposite side is 4 over my hypotenuse or my r, which is 4 root 2. Okay, and if you punch this into your calculator, you're going to get 1 over root 2. Okay, or your calculator is going to be nasty and do this. Root 2 over 2. It's going to do that. Sine of 45 degrees is equal to root 2 over 2. I want you guys to just confirm with me. Punch sine 45 into your calculator and tell me if it gives you root 2 over 2. You can give me a thumbs up in the chat if it does this. Oi, Michael. Amelia, that's surprising. It should give you. Okay, Amelia, remember, don't click shift. Don't click shift. But okay, then make sure your calculator is in degrees. Okay, remember, we need to make sure that that D at the top is colored in. Otherwise, your calculator is going to give you answers in radians or other funky things, and we don't want that. Okay, that's the problem. That ROG is not supposed to be there. You're supposed to have a D at the very top. So you need to click shift mode. Teacher knows, can you just quickly punch those instructions in the chat, and then we'll talk about that. Hi, Unami.
Ma'am, hi, ma'am. Ma'am, I'm having a problem with putting it in degrees, ma'am.
Okay, so teacher knows is going to put instructions in the chat right now. Okay.
Okay, ma'am.
And just follow, do exactly what she tells you to do. Okay.
Okay, ma'am. Thank you.
Excellent. All right, let's try something a little different here. Okay. I'm going to give you guys another coordinate. Okay. And I want to see if you guys can keep up with me as we go along. All right. Okay. I'm going to give you guys the coordinate over here of 7 and 3. Right. So can somebody tell me what is my X value going to be? What is my value on my X going to be? Letso, you are on the money right there. Yeah, let me just, oh, why is it not? Okay, it's not allowing me to do that. Good. On my X axis, we're going to get 7, right? What about on my Y axis, like from here coming down this way? What are we going to get over here? That's it, guys. We're going to get 3. So over here, I'm going to get 7. This is my adjacent side. I'm already calling it my adjacent. It might not 100% be my adjacent, actually. I'm just going to call it my X for now. Okay. Then this side over here is my Y value. And then we need to find, I'm going to make it a solid line because we're always going to find it. This side over here is my R, or my hypotenuse. Okay. Now, we don't know what our angle theta is, right? But what I want you guys to do is I want you to tell me what is cos of my angle theta. Okay. There's a lot of work to be done here, guys. Okay. Any brave soul want to unmute and let me know what kind of strategy we need to use to make these two things work? Anybody got an idea of the things that we would need to do in order to calculate for the cos of theta? Anybody got any idea? Think about it. When I want cos, what do I need to find? Okay, we've got cos, we've got x over y, Google. Is that going to help us? Remember what the car stands for. Oh, Mawande, why did you put your hand down? I was about to unmute you. Okay, good. Mawande says x over r. Good. We know that our car or our cos is going to be our adjacent side, which is going to be over here, over our hypotenuse side, which is our r. Good. So we already know that cos of theta is going to be adjacent over hypotenuse, or it's going to be x over r. Right. Now, who has pinpointed the problem? Anybody? What's the problem? Yes, Shaden.
Ma'am, we don't have the hypotenuse. So is it not supposed to be Toa, I believe?
No. Okay, so Shaden, I can use Toa to find the angle, but I don't want you to find the angle. I want you to tell me how I can the cos of my angle using the sides. So how are we going to find this hypotenuse that we don't have?
Pythagoras?
Yes, Pythagoras. That's how we can find the hypotenuse. We can use Pythagoras. Okay, so we're going to use Pythagoras to find the h or the r, and then we already have x. Yes, we have x, and then we can just rewrite it as x over r. Shaden, that's exactly what I wanted to hear. I feel like you're getting it a little bit. Okay. Loving it. Loving it, loving it. Excellent work. Okay, so we're going to find our R. I want you guys to use Pythagoras. I'm not going to calculate it for you. You are big, big children. Find me R. R is equal to x squared plus y squared. Sorry, R squared is equal to x squared plus y squared. Find me R. I'm just going to write, therefore, R is equal to. I'm waiting for you guys to give me an answer. Whenever you guys are ready, pop your answer in the chat for me. Geez, you, Jonathan and Kamu, you guys are very quick. Kamu, did you find the square root? Because it's R squared, so you must remember to square root, hey? Good, it's the root of 58, good. So our R is the root of 58. R is equal to the square root of 58. Oh, I'm so sorry, my sweetie. Yeah, sometimes it does happen. Good, it's root 58. Excellent. Now, guys, I want you guys to express the cosine of theta for me. Cosine of theta is equal to what? Write it in numbers. Remember, use the ratios that you have. What is my x value or my adjacent side? It is? How much is it, guys? Look at your drawing. That's it, Jonathan. Oh, excellent. That's it. I've got 7 over my R or my hypotenuse, which is going to be the root of 58. Okay. All right. Now tell me, guys, thumbs up, thumbs down. How are we feeling about the Cartesian plane? Is it difficult? Google's like, easy, easy, ma'am. Shaden, I agree. It does take a bit of work. It does. It takes a bit of getting used to. Stefanina, if I've lost you somewhere, please give me a detailed explanation of where I've lost you so that I don't leave you behind. Okay. Oh my goodness. Guys, if you're like, I understand nothing, I need you guys to, okay. I understand that some of you guys are joining us in lesson 5 of 6 when we've already had lessons 1 to 4. So there's quite a bit that you've missed out on. Okay. Okay. But if you are kind of understanding where I'm coming from, okay, it's not that deep in grade 10 yet. It's gonna get there at a point, but not yet. Okay. All right. Hi, Mawande.
Ma'am, my
Yes,
answer
sir.
for R, the radius is 7.62. Does that still count for, or?
Well, yes, it does. But you know what the problem is, Mawande? You've rounded up, have you not? You've rounded off your answer.
Yeah, because I think I did. I went a very dumb route or out of route somewhere there.
Okay. Yeah.
So I did something like this. So I did.
Okay. So when your calculator gives you the square root of 58, leave it as the square root of 58. Because if we start looking at the decimals, it's gonna start messing with the answers that we're normally gonna get. Okay, because now you're making the number shorter instead of giving us the true value, which is just the square root of 58, because the square root of 58 is an irrational number. Okay, so leave it as the square root of 58. Does that make sense?
Yes, ma'am, because yeah.
Okay. Oh, sorry, I cut you off. I'm sorry, my sweetie. Yeah, so basically, guys, if it says square root of 58, leave it that way because it's an irrational number and it has non-terminating decimals, and we're not going to be able to write them all out. Okay, hi, Shaden.
Ma'am, I just want to say, in grade 9, the Cartesian plane used to be so easy where it was just the coordinates. Now it is like so much more. It is so much more and so confusing, ma'am.
I know, and it's going to get a little bit when we start functions are going to be a lot. they're going to be a
Okay,
lot,
but
and you're going to have to keep
let me
it
just tell you
moving.
something. Let me just say something that for those of us who don't understand it, we're going to get there, man. Trust, we are going to get there. We are going to get there.
That is the attitude I was hoping for. You see, Shaden, you're like literally our hype person. That's exactly what we need. Yes, you are going to get there. I believe in you guys. I believe in you. You're going to do it. 100%. Love it. All right. Okay. Guys, we're not going to focus on this a lot. Okay. We're going to be focusing on special angles, but I want you guys to take a screenshot of this. Okay. I want you guys to take a screenshot of this, and we're going to go and practice. Okay. I'm actually going to change this to a 6, and I'm going to change this to a 5. Okay. I want you guys, this is your Cartesian plane. Remember, this is 0 degrees, 90, 180, 270. And when we come back around, this is also 360 degrees again. And I want you to practice finding the sine of theta, the cos of theta, the tan of theta, using our x coordinates and our y coordinates. And also, guys, I want you to find theta. I want you to find theta. So the instruction is find the sine of theta, the cos of theta, the tan of theta, and also find theta. Okay, find all 4 of these things for me using these coordinates that we've got over here. Okay. All right, I'm going to leave it on for 10 more seconds so everyone can take a screenshot. Guys, it is very important that we understand the fundamental concept of what just happened. Okay, because later on, I'm no longer going to use SOHCAHTOA. I'm going to use a completely different one. It's going to mean the same thing. It's just that I'm going to put X and Y and R instead of O and A and H. Okay, so we do need to practice. Letu says, okay, so here's what's going to happen. Letu, we're no longer going to be writing SOHCAHTOA. We're going to be writing S is equal to Y over R, C is equal to X over R, and T is equal to Y over X. So this means that sine is equal to the Y over the radius, cos is equal to the X over the radius, and tan is equal to the Y over the X. Okay. I'm sorry, I know, Nkankla, it's so mean of me. Just as we're understanding the SOHCAHTOA, we just add something else in. I'm sorry, TD.
Is it possible to still use the SOHCAHTOA, Teacher Coco? Is it possible to still use SOHCAHTOA and be like adjacent is X, opposite is Y, or does those side changes if you have?
Actually, it is still very possible because we're going to be focusing our angle on the x-axis. You know, so
and you're only working on the first quadrant. So
yeah, it's going to work here. And then even if we go all the way around, it's still going to work because our x-axis is our reference. So yes, it's still, to an extent, it still will work. So you can use opposite and adjacent and hypotenuse, guys. You're just going to have to remember, after you use the adjacent and the hypotenuse and the opposite and the whatever, to replace the O with a Y and to replace the X, the A with an X. Okay. I know, guys. We're not going to leave it behind. All right. Okay. I need you guys to take your calculator. Take your calculator, close it, and put it far, far away from where you're sitting. Like far away. We're not going to be using our calculators anymore. I literally just threw my calculator across my room. Okay, we are no longer going to use our calculators anymore. And Unati's like, it's gonna go down. It's about to go down. You know what I mean? You know what I mean? Like, Moteo's like, hashtag, gently puts it next to me. All right, we're going to be learning about special angles. All right. Now, what special angles are, guys? Thank you, Teacher Nels. Don't throw them across the room. Do not throw them across the room. All right. So there are certain angles that we use constantly. Okay. And Reaboka, it's not as bad as it looks, I promise. Okay. There are three angles that we use more often than others. In fact, I think there are 5 of them. We're going to stick to 5. Okay. We're going to stick to 5. The 30-degree angle is going to be very important for us. The 45-degree angle is going to be important. The 60-degree angle is going to be important. And I'm going to add 2 more. I'm going to add the 90-degree angle. And I'm going to add the 180-degree angle. All right. Now, it's not going to be that bad, guys, because what we're going to do is we are going to memorize, we're going to commit to memory these 2 triangles, this one and this one. We're going to commit to memory the 60-30. We're going to call this one a 60-30 triangle, a 60-30. And this one is a 45 angle, triangle. Okay. Oh, Makoloba, I will in just a little bit, my sweetie, so you can take a screenshot. Okay. Now, the reason why we're going to call this triangle a 60-30 is because I know that in a right angle triangle, when we're using Pythagoras or if we're using trigonometry, if this angle is 60 degrees, that angle over there is automatically 30 degrees. So that takes care of 2 angles in one. It takes care of my 30-degree and my 60-degree. So that's why I'm calling it a 60-30. You can call it a 30-60 if you want. It won't make a difference, but we're going to use it that way. Okay. And then my 45-degree angle is also self-explanatory, guys. If this angle over here is 45 degrees, this other angle over here will also be 45 degrees. So we're going to have to commit these to memory. Okay. So we're going to have to remember, it works easier for me in my brain. I don't know which one will work easiest for you in your brain. When I see my 60-degree angle, I immediately go 1, 2, √3. Okay, did you guys see the order in which I did that? 1, when I see 60 degrees, 1 is my adjacent, 2 is my hypotenuse, 3 is my opposite. Okay, that's my 60 degrees. 1, 2, √3. Okay, I'm gonna be nasty just for a quick second. Okay, I want you guys to tell me very quickly in the chat. When I see my 60-degree angle in a triangle, what are the 3 things that I remember? Give them to me in the chat. I just mentioned them. That's it. Unati's got it. 1, 2, √3. That's it. So we're going to memorize 1, 2, and √3. But it needs to be in that order, guys. The adjacent, the hypotenuse, then the opposite. Okay. That's okay, Zudine. That's okay. Good. It's going to be 1, 2, √3. Okay. And then we're going to use this. We're going to use this to figure out the rest of it. Because if I know what my 60-degree angle is, okay, if this is adjacent, if 1 is adjacent to my 60-degree angle and my hypotenuse is 2 and this side is √3, if I then change my theta to 30 degrees, it doesn't matter. I don't have to memorize that one because I can then just remember that this is my adjacent to my 30 degrees. This is my opposite to my 30 degrees. And this is my hypotenuse. Okay, so we're learning 60 and 30 degrees at the same time. Okay, we're learning 60 and 30 degrees at the same time. Okay, and then Puseleta says, ma'am, why is it √3? And I was waiting for somebody to ask this question. Okay, this is why. Because if I want to calculate for my hypotenuse, Puseleto, if I have this side and I have this side, my formula for Pythagoras says my adjacent squared plus my opposite squared is equal to my hypotenuse squared. If I have my adjacent and my hypotenuse, I'm going to make my opposite the subject of the formula. So I'm going to take my adjacent over to the other side of the equal sign. So it's going to become minus. What I'm going to end up with is opposite squared is equal to hypotenuse squared minus adjacent squared. If I put this into my calculator, Puseletso, what is my hypotenuse side? How much is my hypotenuse side? It's 2 squared minus 1 squared. And in order to find my opposite, I have to take the square root of this. So if you punch this into your calculator, it will give you the square root of 3. Okay, that's why. It's a far off explanation of why we get there, but at this moment, it's not as important as us remembering, excuse me, it's not as important as us remembering the 1, 2, root 3. Okay, so adjacent, hypotenuse, opposite. 1, 2, root 3. Okay. That's the importance part. Okay. I know, Puseletso, I know what I mean. I know what I said. I know what I said. Do as I say, not as I do. Okay. Okay. I know. I'm sorry, Muteo. I'm sorry. Okay. So we're going to remember 1, 2, root 3. Now, for our 45-degree triangle, we're going to remember 1, 1, root 2. Okay. So my short sides are both 1 and 1. And then I've got root 2 on my hypotenuse. Okay, so we're going to try and commit this to memory. It goes a lot faster, especially in grade 11 and matric, if you are already familiar with the special angles. Now, I want us to use the special angles. I'm going to leave them on the screen. I'm not going to take them away. I want us to look at our special angles over here, and I want you guys to tell me, what would the sine of 45 degrees be? Look at your special angles. Now, because it's sine of 45 degrees, I need you guys to go to the 45-degree triangle. I need you guys to go to the 45 triangle, and I want you to type in the chat, what is the sine of 45? Now we need to remember, Sokatoa, sine is equal to opposite over hypotenuse. What is my opposite side? Kamu, you're correct about my opposite side. My opposite side is 1. Over, that's it, Mawande. What is my hypotenuse? Root 2. Okay. So we're going to use the triangles to figure out the sides. We're not going to use our calculators. We're not going to need them. Okay. It's going to be 1 over root 2, or as Gugu says, root 2 over 2. There's a reason that is. It's called rationalizing the denominator. We don't do that in grade 10. We do that in grade 11. Okay. But we're going to be looking at it from that perspective. All right. Let's think of cos of 30 degrees. Cosine is ka. Shaden. Okay. Shaden, have a look at this next one. Cosine of 30. Remember, cos is adjacent over hypotenuse. So we need to go to our 30-60 or 60-30 triangle. And here is my 30 degrees. So what is my adjacent side to my 30-degree angle? It's root 3. And then I write root 2. Hi, ma'am. Root 3 over my hypotenuse, which is 2. All right, let's try that again. I'm going to try that again. I don't want to lose you guys. If I want to find the sine of 45, I'm going to go to my 45 triangle. And I'm going to go sine is opposite over hypotenuse, which is then equal to, what is my opposite side to my 45-degree angle? Opposite is 1 over root 2. Okay, my hypotenuse is root 2. When I need to go to my cos of 30, I need to go to my 60-30 triangle, and I need to look at where 30 is, and I know that cos is adjacent over hypotenuse. So in this case, I'm going to get my adjacent, which is the root of 3, adjacent over hypotenuse, the root of 3 over 2. Okay, now I want you guys to do this one. Give me the answer in the chat, guys. What is sine of 30 degrees? Use your 60-30 triangle and tell me. What is sine of 30 degrees? Thank you, teacher Nels. I know I'm going to have to go. I'm going to have to go. Tell me in the chat. Sine of 30 degrees is how much? Use your 60-30 triangle, guys, and give me an answer in the chat. Ooh, Unati 0.5 is not going to help us. Unati is using a calculator, yes. Google's also using a calculator. Good, it's 1/2. Good, 1/2 plus what is cos of 45 degrees? Now I have to go back to my 45 triangle. That's going to be 1/√2. That's it, Mawande. I'm writing in highlighter. 1/√2. Okay, and that's how this works. We're going to pick it up from here.